Okay, so my paper is actually about noise and emissions, if you read the preprint. So it's not only noise. I focus on estimating the environmental impacts of airport operations on my PhD. Yeah, I'm Gonçalo. I'm a PhD student in Aachen, and I'm Portuguese. Short agenda for today, introducing the topic. Then I'm going to introduce the automation I built on top of the traffic library by Javier to automate the estimation of noise and fuel and emissions for each individual arrival or departure for a given airport. And then I'm going to show you some results for applying this automation to a use case of the Cologne-Bonn Airport, where I got some validation data for the noise part, and finally my conclusions on some further work. So I'm kind of an airport guy. I've done in my previous research and work a lot of work with airports. Specifically, Cologne was one of them, but specifically on airport environmental impacts, starting with noise. And it was always kind of a pain to estimate, to make noise simulations for large scenarios and to estimate noise for smaller groups of flights. There was always a data collection process. Well, at the time I was mostly not even aware of what the Open Sky Network, that was like 6 years ago. There was a data collection process, data processing, database collection, selecting a simulation tool, which are mostly commercial tools, and so on and so on. That was very tiring until you got to the end result, which is some noise map, or in my case, from some previous research, also some noise values for single locations. And so I went on to improve that situation a little bit, and this is a bit the result you can see here from that. So in this particular specific work, I'm developing a capability to estimate noise and emissions from network data, from Open Sky network data. And then I want to use this capability to be able to fully automate the reporting of noise and emissions for any group of flights, or for any even number of flights. Of course, that the validity of the results, especially for noise, is dependent on how many flights you are considering. To clearly define here my scope, I am focusing on the airborne part of airport operations, so everything which is taxi in, taxi out, or outside of the arrival and departure phase is not of my interest. And yeah, everything which is above, let's call it 10,000 feet, is also not of interest for me, probably even lower than that. For emissions, definitely lower than that. And for noise, probably above 6,000 or 7,000 feet is even not more relevant, but I filter the data I get from Open Sky at 10,000 feet. So that's my scope. I am not calculating emissions/Persian, which is, besides knowing where the emissions took place, which is what I'm doing, calculating just quantities of emissions. There's also models to estimate all those emissions dispersed to the population on the ground, but that I am not focusing on. In the initial implementation of this capability, and I must remind you, it's initial, so it's a first implementation, which can be iterated upon. I am using the noise model specified within the Doc 29 and the fuel flow model specified on Doc 9889, which is based on the LTO values you get from certification data of engines. And the emissions models are also based on those LTO values, but corrected with the Boeing fuel flow method 2, which is one there on the bottom. So this is quite a lengthy automated process. So let's see how kind of it works and what data it uses. We start by basically, or how it should work, let's call it like that. You start by selecting some airports, an airport in a time frame, which could be how many months and what number of airports you want. The process then goes into the Open Sky network, fetches the ESP data around a certain bounding box around your airport, and up to these 10,000 feet, although you can edit that as you want. Then it goes into filtering. We heard a lot about filtering this morning. Filtering there means as well not only filtering the trajectory itself, but filtering also for flights which we or I decide are not of good enough quality, or I don't have enough data to do the estimations. We filter with smooth as well. Then we get the trajectories, and then unfortunately the data we have on the OpenSky or on the DSP messages is not sufficient to estimate noise and emission, so we need to enhance that data a bit. The biggest and hardest part is the thrust estimation. I provide an initial, I call it simplified, maybe even implementation. I know that there is one by Shumzi, I think, of also estimating thrusts based on a different model. That might be a topic of further research to look into that. I provide an initial implementation based on the NOC29 model. Yeah, so we enhance that data, I had the weather data into it, and then I use an environmental impact calculation engine, which we developed at WTH Aachen, called GRAPE, which is not part of this research or of this paper, but I will make a small excursus explaining it to make the calculations themselves. So what data are you using? The OpenSky network, of course. Aircraft data from the OpenSky as well. Airports data we access based on the Javier library, which I think uses our airports. Weather data from the IEM to get metadata, that is like every half an hour weather reports at airports. We then use here these databases which are used by the models I mentioned in the previous slides. The NOC29 noise model uses mostly the ANP databases, and for emissions I need these two on the bottom to get those LTO values. So this slide is trying to explain how I solve the problem of associating what we get from OpenSky. So from OpenSky I get the trajectory, but I don't know which flight, what aircraft is flying that trajectory, or more specifically, I don't know which entries to use in each of the databases that I have and that I need in order to estimate noise and emissions. So I work with what I had, and from OpenSky we do have these aircraft tables containing the ICAO code of the aircraft and an engine description. And I use that to associate this ICAO code engine description with which one of the databases I require. In my case, the ANP database, and either the EEDB or the FOE databases for emissions. The association between one OpenSky aircraft and one ANP aircraft is made automatically, because in the ANP there is also a grouping according to ICAO code and engine descriptions, so we can compare those and see which is the most similar match. And for the EDB, I had to make a manual association between each of those ICAO codes and one engine in this EEDB database. The EEDB database is not an aircraft base. It is a database which is established during engine certification processes, so each entry is for a specific engine. Okay, the next part or problem to solve is this enhancement of each trajectory point we get from OpenSky. Filtering and smoothing, I just wrote really fast. I'm not going to go into details of exactly what I do, but if you remember the talk from Javier, I'm using basically the default values of the rolling window of 5 with the mean, medium. So just everything kind of the defaults. This will just be a baseline which can be iterated upon if we find settings which give better results. I listed there the features which will also be helpful or could be used by the noise models and by the emissions models to adjust estimations. Some of them I do ignore currently, and that's the rest I calculate with the performance model. This is the biggest assumption I make in my paper, because the thrusts, to calculate thrusts, you do need some sort of idea of the other forces acting on the aircraft, and that I don't know currently, so I just used assume maximum takeoff weight for aircraft for departures, and 90% of the landing weight for arrivals. Yeah. So once I have the trajectories processed, filtered, enhanced, whatnot, I can calculate noise and emissions for a single flight. But the reason I can automate this is because of this tool we wrote at the WTH. So it's developed in C++. Everything else I mentioned was implemented in Python on top of a fork of the Ravier traffic library and a separate library of my own where it's just really airport-specific data. The reason we use this is because we want to automate things. So we want to be able to add input data and read out output data and make the calculation runs without user input. So it needs to be automated somehow. And we provide that. And it's also open source and available on GitHub, which was not the case for any of the other commercial tools I've found around. Okay, so then when I had this automation kind of developed, I made my inputs into it based on a validation data set which I had from the Cologne-Bonn airport. So I just gave it Cologne-Bonn 2019, and yeah, pretty much that was it. The validation data set I got had these metrics here, approximately 134,000 flights, and that number of noise events for the noise stations. Of course, I cannot, so the overall goal of this exercise is to provide some hint at the accuracy or validity of the results I am producing with associating this OpenSky network data with the databases I have for noise and emissions and the models. So an overall idea on the accuracy of the results of this automated process with all the assumptions it has and all the models it uses. Of course, that is very hard to do for emissions because I do not have validation data for emissions. I think there's very, very little data sets for that with very little data. So unfortunately, I cannot do that. But as I mentioned at the beginning, I work from an airport's perspective, and from an airport's perspective, airports are reporting their emissions according to the LTO cycle, which is a fixed reporting method. So it means that it is independent of the aircraft trajectory. So an aircraft arriving at Cologne or Toulouse, it's the same. If it is the same aircraft, it gets the same number of fuel and emissions reported from an airport perspective. And I can evaluate that. So that is the second analysis I'm doing on the emissions part. On the noise, I do have this validation data set from Cologne, so I can compare I have not done yet to work of comparing each individual flight, so I can actually try to match each OpenSky network noise event to validation noise event, but that I've not yet done. I am just going on aggregate metrics. This is just a small visualization of the data I got from Cologne. The density plot on the background is actually from OpenSky, not the one from Cologne, because I'm just interested on the noise events, not on the radar data itself. So you see in Cologne, we have a very homogeneous aircraft type distribution. So the top 3 aircraft make, I think, more than 70 or 80% of the flights. And here we have the noise events per station. You can see that they are very heterogeneous here. So I actually selected, based on an arbitrary metric of 5% of total flights, I selected which noise stations are relevant for each flight type aircraft, so arrivals or departures. Okay. Then after getting the data from OpenSky and running it through this pipeline, I have per arrival or per departure the noise levels at each of the relevant noise stations, and I have the emissions levels in general for each flight. In terms of flight numbers, I got 81% of the flights in the validation dataset. I don't know if that is realistic, if this is plausible with what you have seen in other work, or if that might be an error somewhere on my pipeline or on my part. You see here some of the filters I mentioned I was setting to ensure that the data which I get from OpenSky is at least to my point of view somehow usable to estimate noise and emissions. The filters which leave out most of the flights are probably here this ICAO code not being attributed to one of those ANP aircraft which I mentioned. I think that is probably because of some entries or errors in the aircraft database, because when I did the same exercise for the validation dataset, I got to 99% of flights from the validation dataset were able to be attributed to one of these ANP substitution aircrafts. On to the results of this validation exercise. You can see here some for arrivals and departures split. Of course, the count is just the percentage of noise events at the relevant noise station between OpenSky and the total the dataset, the validation dataset. And then you have the deltas for the maximum noise level and for the sound equivalent noise level, and also the ear noise level calculated. You see for arrivals kind of a mixed result situation, depending a lot on the location of the noise station. And for departures, we kind of got quite promising results, I would call them. Here, the whole histogram plotted for the sound equipment level. On the left, a noise station which is quite close to the airport, the M05. On the right, a noise station which is a bit more farther away from the airport. So when the aircraft is not yet fully configured for landing. In the paper, I kind of try to provide my explanation of why these discrepancies happen. Of course, I cannot be 100% sure of exactly why these discrepancies are happening because, well, there's multiple assumptions, multiple discrepancies which I made on the automated pipeline. So, yeah. Here the same for the departures. Again, the M08 is relatively close to the airport, maybe still either at the thrust getback point or just after, and the M18 is a bit more farther away. An interesting result, at least I think it's quite interesting, we see on the left, although I assumed max takeoff thrust at max weight always used for departures, the histograms kind of still match. We do have these relatively high values for the maximum metric above 77 decibels, where there are more events on the OpenSky network than on the validation dataset, which could be attributed to this assumption of always using max weight. Further away from the airport, the results are not as promising, especially for the sound equivalent level metric. And here I hinted that it might be just an error in the ANP database itself or on the noise power distance tables that it uses, because the corrections which are calculated and the calculation method is actually quite similar between the maximum level and the sound equivalent level metric, but we obtain very different results for both. Okay, and finally the emissions results part. So calculating emissions is also, or according to our models at least, is based on fuel flow, and we calculate. Therefore, I also need to present the fuel calculation, and the total of emissions is then the fuel flow times some emission index, or the fuel quantity times some emission index. And calculating the fuel is based on time. That's why I also show time. Time is actually probably the most influencing parameter here on calculating the difference between LTO cycle emissions and emissions calculated with trajectory data. That's why I show it kind of big on the top. Remember, the LTO cycle is a fixed reporting method. That's why you see the red value. That is like the LTO time, cycle time for every arrival on the left, 4 minutes, and departure on the right, 3 minutes. LTO cycle reporting is always done up to 3,000 feet above ground level. So this is the assumption from, I believe, Isakeu, that on average, every arrival spends 4 minutes below 3,000 feet, and every departure 2 minutes and 50 seconds approximately. This is the results for the Cologne airport. For the arrivals, we are quite on target, and for the departures, not so much. For the arrivals, I would believe that it is very airport specific. Time spent below 3,000 feet. That should be around the altitude that some airports use to make sequencing. So it could be a lot different for other airports. For departures, not so much. Probably maybe an influence on the type of aircraft used at Cologne. It's mostly narrow bodies which climb quite fast, so that might be the issue there. And here you will see the overall differences between average obtained with the SP data and the fixed LTO values for different aircraft types. The values are mostly between the 10 and 20% absolute value difference. For arrivals, mostly all negative, of course, due to the time part. And for the arrivals, there is a mix. Here in the paper, I also go into trying to find differences not only on the time part, but also on the difference between average full flow and LTO full flow, and average emission indices for the different emissions, and the emission index from the databases, basically. It's a bit quite hard to do, because in each value, for example, here for the departures, there is 2 phases involved. There's the takeoff phase and there's the initial climb phase on the LTO cycle. So there's 2 emission indexes per aircraft there. And so this exercise becomes a bit complicated, but I could improve what I've done here by maybe estimating not the average hydrocarbons in grams as it is displayed there, but I could actually estimate the average emission index, so it would be grams per kilogram of fuel, and then comparing that value with the one in the LTO cycle. Same goes for NOx, and in the paper I also have carbon oxides and non-volatile particulate matter. So arriving at my conclusions, just a recap. We were able to develop here a calculation pipeline building on top of Javier's work and the Open Sky network. And we used as detailed data as we have openly available to estimate noise and emissions. Applying to one validation case, we kind of got mixed but promising results on the noise part, and we could also provide an alternate method to report emissions or to estimate emissions for airports. For some future work, I would really like to see how these environment impact results change when I change some of the assumptions I have on the work, on the calculation pipeline. Probably most interesting is this thrust estimation method, but also on considering other parts of the estimation which I do not yet have in that automated pipeline. And very important, I believe, and I invite you to do so, if you know anyone which has connections with airports which have nice noise measurement systems and want to use those for some nice purpose, then maybe they can also provide more data to see if what I am getting is just a random statistical, maybe just happens, or if it can be replicated at other airports which use which have other operational realities. I think that will be that for me, and I am very much looking forward to your questions.
Thank you. Questions in the room? Let's start with Xavier.
Thank you for this presentation. Could you come back to slide 14, I think it was? Yes, here. I was just wondering why you get 2-mode distributions with CDSB and 1-mode distribution for your validation.
Sorry, can you repeat the question? Why?
Like the orange Gaussian is a 1-mode, like looks reasonable as a distribution, but the green one looks like there's 2-mode, like there's a gap. And sometimes around 80 dB or around 70. Yeah. And I maybe you explained, but I missed what the explanation why there is this this little bump.
Well, why it doesn't show in the validation, I'm not so sure. In the SP data, I'm like, this is all types of aircraft in there, right? So it's a 747 and it's an A220. It's in there, so it's the actual shape of the distribution itself is not that much same, because it is going to be very influenced by how many aircraft are flying of each type, and I do not have a direct correlation between ADSP data aircraft and validation data aircraft. If I did that work, then I could actually show not just between these graphs, but for specific aircraft, like trying to make that comparison. But the short answer is I could not find a specific reason why there is 2 bumps on the ADS beta, other than maybe other types of aircraft flying there.
Yes, okay, let's start with you.
I have a question. I don't know if maybe I missed it, but your validations data is coming from whom?
From the airport itself. It's was provided by the airport for this specific use case.
So you have the exact flight list of the flights that you're going to analyze. That's right.
Exactly, yes. It's the airport AODP, the airport operation database, is with the flight logs and the actual where the noise measurement system from the airport actually records the noise events. There's some processing in there because the airport actually has workers taking care of that database, and sometimes there's just an ambulance going by and then there's a measurement of an ambulance there. So it's a bit more reliable than open source noise measurement databases, which I do know exist, but I also do know of their shortfalls. For this specific use case of validating what I am estimating with the Open Sky network, having the certainty that the orange values are within 0.7 decibels was quite good. It was quite...
that was my question, because otherwise I could have had to give you the list from us.
Have you looked at the open source stuff? Like I know Amsterdam people are using Open Sky and app to basically measure and correlate noise there.
Do they publish their noise values open source?
I don't know if it's public for everyone. It's a crowdsourced effort, so I expect you could get it for sure.
I will have a look.
Are you aware about this product or framework Impact, which is provided by Eurocontrol? Have you tried to use it?
Yeah, sure, but Impact is, well, did not fit my requirements, let's call it like that. Like I need, for this use case, you need I need to be fully capable of automating the input generation, the output generation, and the calculation runs.
So it's not open enough for you instead.
It's not automatable enough for me, and I also it's, well, Impact is quite good actually in that regard. Like it kind of is very transparent in what it is doing, but not that transparent for me.
I see. We just published the paper on OpenSky a couple of years ago for some calculations for 3 airports. So if you're interested in comparison, you can try.
I do know that I've used Impact before quite a lot, but for this specific use case, I believe it will be quite hard to make an interface where you can just specify airport and time frame and get noise results and emissions results from that. Besides that, in the modeling capabilities of impact were also a bit lacking, especially in the emissions part. It was quite nice to be able to just use something which is kind of open source and we can iterate upon.
Nice initiative. Good luck.
2 main questions.
Wow, okay, that's a long question.
Very long question.
Let's start from
With
the
the
first.
short question. Shall I read it out?
You can read
There you
out.
The question is, how do you go from the hex ID that is given by the transponder to the number of the noise certification? I don't. Well, I'm just using the data available on the OpenSky network, which has this aircraft list. So for each trajectory, I get an aircraft code, aircraft ICAO code and engine description. And from that data, I can go into both my noise database and both my emissions databases. From the hex ID, I don't. And the second question, should I read it out as well? From my observations while working with real radar track simulations, I've noticed a significant lack of comprehensive radar data, particularly for general aviation aircraft, but also to a lesser extent for commercial flights. One notable challenge is that many radar tracks are poorly defined or incomplete. When comparing real airport departure and arrival data provided direct by the airport, I found approximately 30% data loss. This gap forces us to duplicate the reliable radar tracks we have to represent the actual traffic volume more accurately. Another issue is the reliability of low altitude position data for noise simulation purposes. It's crucial to accurately define noise contours around airports. However, inconsistencies in low altitude data affect the precision of these noise contours. Ontario's thoughts on these challenges, and greetings from Brazil. Yeah. Hola. Well, my thoughts are that I did not know of this. I did not put too much effort into making sure that that each of my trajectories was extremely accurate and that extremely a very high percentage of no inaccuracies in there. I take a different approach. Let's just calculate it with what we have. Let's just make the default filterings and default smoothings and whatnot, and see what we get. And I would argue based on if you're talking noise specifically, I would argue based on the results we got that it is not looking that bad. I mean, when you talk about noise contours here, we are calculating for specific points. So it is like just a point-wise calculation. Using this data to estimate noise contours will take quite a lot of more time because we are multiplying our calculation by 100,000. And so that would be a different challenge. What I've seen mostly is people using radar data to make some averages, and then of course you're going to have problems. But yeah, those are basically my thoughts on that.
I think we can take it because since we just came from a break and are going into a break, it's okay.
So, do you have an algorithm that takes defined flight events from OpenSky, from which the dBs can be calculated? How close do you think your result would be to a physical noise monitor by minute, not in real time? Well, do I have an algorithm? I don't call it an algorithm. I call it just like it's a multiple calculation steps, one after the other, using multiple interfaces and multiple data. So I don't really call it an algorithm, but yeah, I have an automation pipeline which does that for a flight, not for segments. So it's just for a given for each flight, you just get one noise level per position. If you're actually talking about calculating for each segment, you are calculating, so for each second of flight, basically you're calculating what is the noise level at any given location you want. For that, I would not recommend this. You need to look into different noise models, or at least if you're trying to compare those with real live noise measurements, probably these will not provide you the most possible accurate results because of the assumptions which are made in the noise modeling part. But you could try. I also just tried this and saw what I got. So you could definitely just try that and see what you get. With computation, it will be even more problematic than what this already is.